Hello students, hope you have settled down for the lecture on theory of machines. We are going to start off with the most basics, and whenever we talk about a machine is made up of n number of links which are having relative motion with respect to each other. So, the most basic element or part of a machine is a link or element. It is a part of a machine which is having relative motion with respect to some other part of the machine. A link or element is a part of a machine which is having relative motion with respect to some other part. Now, when we talk about the links, there are different types of links. The first one is the rigid link. In a rigid link, the deformations are negligible under the application of external forces or loads. Examples of the rigid links are piston, crank, connecting rod, cylinder, and so on. The second type of a link is a flexible link. In a flexible link, the deformations are permissible, but within certain limits. Examples of the flexible link are belt and rope drives. The belt is a flexible link. Therefore, a link need to be a resistant body. A link need not be a rigid body always. The third type of link is a fluid link. In a fluid link, the force or power between the two links is transmitted through the fluid pressure. Example is the hydraulic brake, hydraulic coupling, hydraulic intensifier, and so on. In a fluid link, the force or pressure between the two links is transmitted through the fluid medium, that is the fluid pressure. Now, we have talked about a link. When two links combine, they form a pair or a joint. Now, when we say a pair or joint, it is a combination of two links. It is the combination of two links having relative motion with respect to each other. Now, after we define a pair or a joint, we have seen that between the two links there will be always relative motion. Now, we have to see what are the different types of relative motions that exists between two links. Types of relative motion. First type of relative motion is completely constrained motion. Let us understand this with the help of an example. Let us take a block which is fixed, and let us drill a rectangular hole in this block. And a rectangular cross sectional shaft is moving inside this rectangular cross sectional hole. Now, let this be link 1 and let this be link 2. A link can have any shape. Here between link 1 and link 2, if we are defining this as the boundary. Now, boundary is one which separates the system from the surrounding. All the elements which are there inside the boundary form the system, and everything external to the boundary is the surrounding. Now, here the link 1 and link 2 form a part of the system, and between these two links there is only translation or reciprocation possible. So, the system itself is constraining the relative motion between the two links. It is a completely constrained motion. The system itself restricts or constrains the relative motion between the two links of the system. The next type of relative motion is successfully constrained motion. Successfully constrained motion. Let us understand this with the help of an example. Let us take a cylinder, piston, and the connecting rod which is connected to the piston. Totally 3 links are present here. One is a cylinder, 2 is the piston, and 3 is the connecting rod. Let us define just the piston and the cylinder as the system. So, as links 1 and 2 are the part of the system, link 3 is external to the system, which is the connecting rod. Say, if the connecting rod is not there, then this piston not only reciprocates inside the engine cylinder, but also it might rotate. We are not able to constrain the motion when the connecting rod is not there. Due to the presence of the connecting rod, it is allowing the piston to only reciprocate inside the engine cylinder. We are getting a constrained motion, and here due to the surroundings, which is the connecting rod, the relative motion between the two links of the system is getting constrained. That is called as successfully constrained motion, where the surroundings constrain the relative motion between the two links of a system. And the last one is unconstrained. Unconstrained or incompletely constrained. Motion. The name itself says the unconstrained motion. We are not able to constrain the relative motion between the two links of a system. Let us understand this with the help of an example. Let us take a block which is one link, and we are drilling a circular hole through the block. And there is a circular cross sectional shaft which is rotating inside this hole. Now, when this circular cross sectional shaft is moving inside this circular cross sectional hole, there is not only rotation of the shaft with respect to this cylinder block, but also the shaft can also translate or reciprocate. So, it is having two motions. we are not able to constrain the relative motion between the two links of the system. That is an unconstrained motion or incompletely constrained motion. In completely constrained motion, we can see that there is only translation present here. In successfully constrained motion also, we are seeing that there is only translation or reciprocation of the piston, but here we are seeing that the shaft is not only reciprocating, but also it rotates inside the circular hole. So, this is unconstrained or incompletely constrained motion.